Alright, perfect. So, hello everyone. My name is Pranay, Narang, and today I'm going to be talking about OpenTelemetry. And just let's dive in real quick. So, my name is Pranay Narang, and I'm a software engineer, backend, DevOps, infra. I handle all of those domains at a small startup called Azoda. At Azoda, we're building the next generation of healthcare interfaces and products that allow organizations to make use of their own healthcare data much more simply. And yeah, let's get started. So let's talk about monitoring first. How many of you here have used Linux in general? Okay, a bunch of us, nice. And how many of you have run something on Linux, like a WordPress website, like a blog or something like that? Okay, cool. So when let's say we're running a blog on our on our Linux server, right? Let's say we have a WordPress blog that we're running on our Linux server. Now this could just be a small VPS box that we know about. Now the problem is, let's say you're running a blog, you're running maybe like a website where you're selling things, where you're an influencer, you're selling things, you have a product line up there. You want to understand what's going wrong with your system, right? You want to understand when my system is failing. And that's where monitoring comes into the picture. Monitoring is a standard. The term monitoring denotes that you can collect data about various aspects of your system. It allows you to measure the health of your system. It allows you to measure various aspects of your own existing systems. And it also, it helps you detect issues that are happening with your own systems. So let's say something is going wrong, something on your system is, let's say your WordPress website is down, you're not getting any traffic on your blog. Now, there's no way for me to understand that my site is going wrong, right? Unless I go and visit my own website and I see that, hey, something is not working. And it's not just the entire website, maybe some small component of the website could also be down. So it's very important in organizations to detect failure very early, as soon as something is failing in your own application. So WordPress could be one example. For an organization as big as Zerodha or something else, it's very important to detect failure because that directly denotes the organization's success rate, right? If payments have started failing on Zerodha, that impacts a big chunk of the people in the country today. So yeah, that's what monitoring is all about. This is what a standard monitoring architecture looks like. We have a Linux server which is exporting to something called Node Exporter, Prometheus, Grafana. And that's the bare bones architecture. We'll talk more about that in a second. This is what a Grafana dashboard looks like. It looks pretty overwhelming in the start, but it includes some very important vital information about our own system. So let's say this is just a bare bones Linux box which I installed Grafana and Node Exporter on, and it gives me enough information about my system, right? It tells me about the CPU time, CPU utilization, memory utilization, disk utilization, all of those things. And these are important things to measure. Something could be blowing up my disk utilization through my application, and I would not be recognizing that fact, and that could cause my system to fail, which would indirectly cause business failure and so on and so forth. So this dashboard helps me understand a lot of vitals about my system in one go instead of actually going into the system and doing like an edge stop or checking using any of those tools. And yeah, that's the Grafana dashboard. In production, monitoring looks a bit different. So in production, you wanna understand potential problems before they become a real problem, right? Before your system actually gets impacted, you wanna understand that, hey, something in my system was failing. So here we include two more things in our monitoring setup. We have a service X, which could be your own e-commerce website, it could be Zerodha, it could be a number of other systems. You have a Prometheus server, which Prometheus is a monitoring server. We'll talk much more about that later. And you have Alert Manager. Now, Alert Manager helps you manage alerts based on the data that's coming in, based on the data that you're monitoring on your systems. So let's say your CPU utilization is going above a certain threshold. Using Alert Manager, you can set up alerts for that same thing, and you can get notified over Slack, WhatsApp, any of the channels that you're using. And an engineer at your company could look into the same, which solves a lot of issues, right? You're detecting things very early on. You're detecting things as soon as they're about to fail or they've started failing. You're not waiting for a user to report that, hey, your system wasn't working and I could not process a payment, which is not a good picture for your organization as well. When we talk about monitoring in general, there's three very essential aspects to it. There's metrics, traces, and logs. And let's deep dive into each one of those in a second. Now, first one is metrics. what are metrics? So metrics are very small quantitative data points about the system. So it's based on something called time series. Now time series is for a given period of time, do I know what happened with my system at that given point in time? So things like metrics help you monitor things like CPU utilization, memory utilization, request count, and all of these things. Now these are real diagrams from one of our systems, and you can see I have CPU utilization right there, and I can understand that hey, at 4 o'clock CPU utilization was going up a bit, and then between 4 and 4:15 it peaked. So something might have happened in my system that caused that CPU utilization to peak, right? So I can go ahead and debug more that hey, something might be wrong with my system at that point, and I can go and understand what's going wrong there. Same for memory utilization. You can see around 6:15 it dropped pretty hard, right? And we need to understand that hey, why did it basically go down so much in that factor? Which are just debugging points for your own system, so you understand why failure is happening. And request count is a basic measure of what is the number of requests that are coming into your system at a given point. That helps you understand that hey, I had like 159 requests at my system at 4:30. So that's a good measure. That's a good thing to keep track of. And metrics in general help you keep track of a lot of things about your system. So CPU memory utilization being one of them. Can anyone name something else that could be a metric in a system?
GPU utilization.
Sorry?
GPU utilization.
That could be one, yes. Anything else? Disk storage? Sorry?
Number of processes.
Number of processes, yes. That's something very important to keep checking. Anything else?
Disk IO.
Sorry?
Disk IO.
Yes, disk IO is also really important because disk IO, if you're tracking disk IO and it peaks at some point, you understand that hey, my disk might fail. So you need to be aware about that. So yeah, that's what metrics are. After metrics, we have traces. Now traces is a sort of a new concept that has come into the picture. And traces help you understand how a request is flowing through your system. Now traces help you get a detailed picture of hey, I hit an API. Now some of us might have written APIs at some point in our life, and we know that we have a bunch of controller functions that we write for the API. One that receives the request, one that does the processing, one that calls the database, one could be doing something else, and so on and so forth. Now with tracing, it helps me understand to the core that hey, I had a client API, and that API was calling my auth and auth, which is authentication and authorization gateway. After which it was calling the DB, external merchant, dispatch search. So tracing this diagram gives me a really good view of hey, what was going wrong, what is happening in a given request. If I'm making an API request, I know exactly how the API request is flowing through the system. I know what functions are being called by the system, and if anything fails at this point, let's say if the DB call fails, I would understand that in this request the DB call failed, which is why this request could not be processed successfully. And it helps me understand a lot of things about the system, right? Now, if the DB call fails, I could set up an alarm using Alerts Manager to understand that, to get notified about when the DB call failed and if the DB call has been failing for quite a while, which would help me understand that, hey, my DB is down and I need to go and do something about it. This is what an actual trace looks like. I don't know what the green lines are, but this is what an actual trace looks like from the system. This is from one of our systems itself. You have the get platform API. Platform API is one of our projects, and it goes down to middlewares and it goes down to request handlers. This is not a complete trace graph. We have traced only some parts of the system, which is why it's not showing a lot of the remaining parts of the system. But here, if anything fails, and I'm understanding that hey, my user of middleware took 11 milliseconds to run. Tomorrow, if this could take, let's say, 20 ms, or let's say it could go up to 150 ms, I would understand that, hey, my user of middleware is what is bottlenecking my entire request, and that is causing my API to run really slow. So this entire trace graph as well provides a lot of insight about our own system, our own, whatever we are building. So it really helps you understand what is the point of failure, how is my system performing, and so on and so forth. And the last one is logs. Now, logs are just textual. Metrics and traces give you context about like a specific time series or a specific request. Logs in general help you provide much more context about what is happening with your system, because those are straight textual records about your system. you can literally write a console.log with more, which is what we do, right? Most of our applications when we're building out, we just do a console.log. We're not really going out and writing metrics or traces or something like that. Logs are the most contextual piece of information out there in systems today, and even when we're building projects, right? We just do a printf or a console.log, and that's how we debug. So this is an example of a very structured log from one of our systems, from one of our chat servers. So you can see I have a level error, and let's say a request came in and that request failed. I want to see why that request at that time failed. So I could query this by the timestamp, and I could see that hey, I had a JWT expired for that user, and I understood that hey, वो user का token expire हो गया, इसके लिए वो user का request successful नहीं हुआ. So that's enough context for me to understand and reply to a request saying कि why is your system not working. That's about logs. Again, this is what a structured log looks like from the system. So this is the above one is one of our scanning servers, and you can see it's printing out the log for a given service where tagging successful, file is clean, file write successful, all those things. And below is from a managed service on AWS called RDS, which is telling me that hey, my database status is okay. That also helps me understand that hey, my database is functioning correctly and there's nothing going wrong with my databases, so I can rule that out of the picture when checking for what's going wrong. So that's about logs, metrics, and traces. So, and there's like n number of ways today to do these processings, do these things, and the landscape at this point has become really huge, and it's hard to choose. Today, when you just do a Google search for observability tools, this is what pops up, and it's very hard to choose from all of these tools, right? The Grafana, the Zoho, SolarWinds, Datadog, which is the biggest one, and so on and so forth. Now, each one of these tools has their own standard of doing things, which makes it really hard to choose one. If you're an organization, how do you choose a good tool? How do you know that this tool is going to work for me for the next 10 years? So that's what, and you think the architecture standard would look like this, where you have a application and you have an agent from Datadog or Grafana or any of those tools, and that pings into the monitoring service. But that's not how it works. That's not how it actually works in production systems. In the real world, maybe you want to do logs through Datadog, maybe you want to do metrics through Elasticsearch, maybe you want to do metrics through something else, maybe you want to do logs through Elasticsearch, maybe you want to do traces through Jaeger. And it makes it really complicated because now you have to use 3 separate agents in your infrastructure, which really boils up to the infrastructure debt cost is what we call it. And maintaining these 3 agents is really hard, right? For one application, you have to maintain 3 separate agents, which really does not make sense. It should ideally look like this, where you have one single agent, and you can use any tool that you want with your single agent. That brings us to Datadog's, where Coinbase had a $65 million Datadog bill. Now, paying $65 million for observability at any point is an insane amount of money. $65 million just to understand what's going wrong with your system, and that's more than the compute costs. That's more than what they're spending on servers, which absolutely does not make sense. And now if Coinbase wants to migrate out of Datadog, they cannot, because that'll be like a multi-year project, because Coinbase is a really huge application, right? In general, it might have n number of sub-components that they have to migrate, or at least be like a 3-year project for them. With the current landscape, although we hope it should be easy, that's what brings us to the open landscape. With the open landscape, there's a new tool that came into the picture, a new standard called OpenTelemetry, which was born as a part of a merger between 2 projects, OpenCensus and OpenTraces. OpenTelemetry aims to standardize how we do logs, metrics, and traces. So what we saw in the earlier slide, where you have one single agent, OpenTelemetry helps you get to this point where you can have one single agent and you can post to n number of monitoring services where you do not have to use 10 different proprietary agents. And the worst part about these agents is that most of them are proprietary. I do not know what's going on under the hood. I'm just running a binary. It might be, for all I know, it might be sending my own personal data somewhere else. And organizations do really care about all of that. So that's where OpenTelemetry comes from. OpenTelemetry aims to standardize the way you capture the 3 signals that we talked about, which are logs, metrics, and traces, and make it easier and make it the standard way going forward. So with OpenTelemetry, this is what the architecture looks like. It again a bit overwhelming in general, but you have your microservices. It could be anything. It could be an application doing a database call. It could be an application doing a Redis call, and something like that. And you have your infrastructure, which is your Kubernetes. It could be a Nomad cluster. It could be ECS services. Anything that you're using. All of those are able to post logs to a single OpenTelemetry connector, with which you can utilize any visualization tool. Let's say you want to use Datadog for viewing your metrics. You can use Datadog with the hotel collector, and you're not dependent on the Datadog agent in this case. Your infrastructure only hosts the hotel collector, which makes it really easy to, use n number of other tools that you want. So let's say Coinbase was using OpenTelemetry from the start, although OpenTelemetry did come out right now, but let's say Coinbase was using OpenTelemetry from the start. Today, if they wanted to switch from Datadog, all they had to do was change the URL in the OpenTelemetry collector, and it would be that easy for them to switch from Datadog. While today it would take them like 3-4 years to do it. OpenTelemetry also provides like a standardized way to access. It provides APIs, SDKs, and so on and so forth, and like a bunch of other things that you can use to trace and log and add metrics to your existing applications. It has really good support for all major languages as of today, and it helps you avoid vendor lock-in, right? Vendor lock-in is sort of like the biggest problem that a lot of us go through, where if you're using AWS, you have to just keep using AWS because you can't really move on from there. And that's what OpenTelemetry helps you avoid. OpenTelemetry itself includes these specific things called SDKs, collectors, and exporters. So your SDKs live with your your applications that you're building. So let's say you're writing a node server. Your node server would include the SDK for OpenTelemetry, where you could say that, hey, I wanna trace my Node.js server, I wanna add logs to it, I wanna add metrics to it. That's what the SDKs help you with. You have the collector, which lives in the center. Collector has these processes called receive, process, export, which we'll talk about in a bit. Collectors help you gather all of that data. So your SDKs are posting all of that data somewhere, and your collector is receiving that data from your SDKs, which are your resources in this case. The collector is receiving that data, processing it, turning it into a format that you want to use. So collectors also help you with something called scrubbing, data scrubbing, which comes in handy when you're dealing with PHI, which is health information that you want to keep secure. So while you're sending it to something like Datadog, you might want to scrub all of that information. That's what you can do with the collector. And you can point the collector to a number of other tools like Jaeger, Prometheus, or Datadog, any of those tools that you want to use. In the collector itself, you have different formats that you can receive data in. You have the OpenTelemetry line protocol, which is the first one. You have Jaeger and Prometheus, which are the industry standard for receiving traces and metric data. You have processors that allow you to do a number of things with the data that is coming into your system. And you have exporters that you can use to, again, export them into a number of different areas, which could be Datadog, Prometheus, any of them. Yeah, I'll just skip through that. Yeah. While we were about to implement OpenTelemetry, we were just starting off building our application, and we were on a platform as a service vendor called Render. Render was a bit easy to manage. We weren't really scaling, so we just put our application there, and we figured that, hey, it might work out. But then we got to a point where we had support requests come in, and it was getting really hard to trace things, really hard to see what was going wrong with the system, what's going wrong with the users. So we figured, hey, we need to implement a standard protocol that can help us do this. So we figured, hey, OpenTelemetry might be a good thing for us to explore. But as soon as we started implementing, we saw that the Node.js support for OpenTelemetry for logs, which is the most important thing for us. And all of the developers just do console.logs, right? Even in our organization, everyone was just plain doing console.logs, and that's how we used to debug. Logs was in development, which was a big bummer for us, but we found a way around it. We use something called the file log exporter, which is supported by OpenTelemetry. The file log exporter helps you, it takes a file from your std out or from any given file source by your application, and it sends your file to the OpenTelemetry collector, which we figured that, hey, that might work out for us. We don't need to directly send logs to hotel. We could pipe it through the file log collector. So we set up our Node applications to simply just pipe logs to a file. And yeah, that's what got us working with OpenTelemetry, and we did not really have to depend on the specific OpenTelemetry support for Node.js. We just added a Nodal container with our entire architecture, which helped us pipe logs. So Nginx and app containers used to always post logs to OpenTelemetry. That made it easy, and the OpenTelemetry container could just pipe logs whenever we want. And we got to a point where we were able to export logs pretty easily. And yeah, that's what our implementation detail looked like. OpenTelemetry is again that was all about OpenTelemetry. OpenTelemetry is like the second biggest project to come out of CNCF, which is Cloud Native Computing Foundation, and the biggest project to come out of CNCF. Anyone? Yes, Kubernetes is the biggest project that came out of CNCF. It's always looking out for newer contributors, people who can help out with things. So do contribute to things like CNCF. And thank you. That was my talk.